Kubernetes for Humans.
Hello, everyone, and welcome to another episode of Kubernetes for Human podcast. And my name is Itiel Schwartz, and today with me on the show we have Ian. Ian, can you please introduce yourself?
Yeah, my name's Ian Nowland. I'm in Australia by birth. I've lived in the US for about 17 years now. For my last 4 years of my career, I was VP of Engineering at Datadog, running what we call core engineering, which is more as platform engineering. In the last 6 months, since leaving that job, I've been actually running a book on platform engineering, trying to get some of my lessons into writing.
So, Ian, first of all, I'll be honest here, I know Ian for quite a lot of time, I think 2 years, and I think that, you're one of the biggest experts I talk with regarding platform engineering, mainly because you're both in AWS and Datadog, which are two huge companies that sell to the rest of the dev world, basically. So I'll be happy if we can start at the beginning, right? Ian, you weren't born, writing books on platform engineer. Can you please share with us a bit of your background of what made you go into tech, and then maybe on platforms, and then also around Kubernetes, obviously. So in that order, go.
Yeah, it's interesting. My background is slightly not standard for a software engineer, in that I have a mechanical engineering degree. Because back in the day, I was super interested in robotics. This was back at the University of Sydney that had a really good mechatronic engineering program. So I graduated thinking that was going to be my PhD, and I'd go spend all my time on robotics. And sort of two things happened. This was right after Y2K, and so the industry was sort of in a downturn. And I sort of realized maybe PhD wasn't right for someone who really liked shipping code. So I ended up working in industrial automation at Honeywell, and pretty quickly just becoming a pure software engineer. Sort of working on video, ended up working on printers. It was around about 2006 that the Sydney market wasn't great in terms of roles. And Amazon had sent this recruiting team out to Australia. And Amazon back then was more or less a bookstore that just started selling CDs and DVDs. And so I was like, okay, this isn't what I wanted to do, but it's a great step in my career, and they're making it really easy for me to move to the US. So I moved to the US last at Amazon.com for about 2 years, but got really excited by AWS. Again, sort of the infra level. So the first project I did, which you now call a platform actually, but it was Elastic MapReduce, we were sort of taking it to work out how to run it on EC2. But that got me really interested in the internals of EC2. So I ended up 2 years into that, about 2010, I transferred into EC2, and EC2 was just going through hypergrowth at the time. It was, EC2 was essentially open source hypervisor Zen, MySQL, and a workflow, the old equivalent of maybe temporal. And it was just breaking in every possible way you could break under hypergrowth. So it was 2 years of just bailing water, fixing problems as fast as we could. But then out of that, the guy who actually ran EC2 about computers as CNS always had this vision of competing with bare metal. And so I actually got to initiate what's now called Nitro, but back then had a different code name. I was the first person on it. I built that from scratch, built the team up, sort of took it through the first three releases. So if you remember, if you know EC2 instances, it was the C3, the C4, and the X1, three generations of this underlying technology, but completely burned myself out along the path. Basically, in many ways, Nitro became an internal platform to within Amazon, and the politics of it, I wasn't capable of managing at the time. So I did a big career reset, ended up working finance for a couple of years, just working
One second. Yeah, I must stop. I think not a lot of people worked on EC2 back then. So I wonder if most changes were technical, how do I support it and make it work? Or it was more how will people utilize it? Was it more hard, very, very hard technological problems, or it was also on the usability of EC2, who is going to use, how they are going to use, and so on?
Yeah, what EC2 and virtualization looked like at the time, and I guess you see this in the container sort of thing today, was, Zen had lots and lots of bottlenecks around I/O and lots of noisy neighbor problems. And so what EC2 was going through at the time was lots and lots of unhappiness. It's funny, customers called it jitter, and jitter is a very technical term that actually wasn't actually jitter, but it was very much variability of performance. So all the teams that were sort of on the data plane side of EC2, what it looked like was this sort of wire and string of getting Zen into production as soon as possible, just had all these weird bottlenecks where different tenants could cause issues with other tenants. And it was DNS, it was ARP, it was DHCP. Every single thing that could potentially cause a noisy neighbor bottleneck was causing a noisy neighbor bottleneck. So the managerial challenges were, how do you keep growth up, even as all this stuff, like it's very much we had the V1 platform in production that was hyper growing. How do you actually work out how to build that V2 platform? And there was like 10 different ideas. So part of the managerial challenge was like, there were some people who just want to double down on Zen and double down on it. There was the more radical idea that we now talk about, which is offloading it all to a secondary CPU. So yeah, there's this challenge of keeping up with hypergrowth and working out what the future strategy was. That was a lot of sort of the challenges at the time. We hired very good people. Lots of people were super excited to be there at the time. But in the end, we would often get into conflict because we had very different ideas about what to build next. And so yeah, that was a lot of the challenges at the time.
Mm-hmm. Okay, so you left like the AWS in its like early days, right? Like EC2 is still like forming up. And then, sorry, like I stopped you, but you talked a bit about the financial sector.
Yeah, the financial stuff was honestly, it was the only time I've done pure platform engineering because we were actually, our play, which is now very standard, was using Kubernetes to pivot from on-prem to the public cloud. We're going hybrid on cloud between AWS and Google. But really the reason for Kubernetes was the fintech houses that had been very successful on-premise and couldn't move out of the data centers all that quickly. So it was funny, we pivoted, and this is actually done before, we very observant, they pivoted from Mesos to Kubernetes, and that was a good decision. But then very early on Kubernetes, so going through all the Kubernetes sort of hype cycle,
let's just be like what year, like what Kubernetes version, what company, if you can say.
Yeah, this is where as a manager, I'm going to be horrible at the actual Kubernetes version. It was not where like even an etcd upgrade was super painful for us. This was back very early on. So I got there in 2016. They started in 2015 with Kubernetes. So
yeah, quite early.
Yeah, very early. And a lot of the challenges, again, a lot of it was like, how do you just upgrade these clusters without moving people off? Like it was that challenge. But then like a lot of it, this is sort of, my fascination today still. A lot of the challenges was just on the network part. Like they had like their own in-house network attached storage system. Like it was very NFS-y. They had just a lot of problems in terms of how legacy software was written that didn't look anything like, this cult of containerized stateless, didn't look anything like that. Batch scheduling, they had a massive batch workload that Kubernetes didn't do anywhere near as well as Mesos at the time. So it was lots of things like that we had to tackle to make it. The other part of it, honestly, they had this was an old hedge fund. They had 10 years of tech debt in their own system. So it's the classic, how do you bring all that long tail of historical decisions onto this very, very modern platform? So that was all the problems we were tackling. So yeah, did that for a couple of years, decided though I much prefer building tools to using vendors' tools.
One second. No. I will stop you because I think that's also a super interesting point. I think most companies, especially those who make money, are not necessarily cloud native, right? Here at Commodore, super cloud native, everything from the ground up. There was Kubernetes, everything is great. But I think most of the industry, the huge majority of the industry, is much more of the place that you worked in, right? They are not a tech company, right? They are a hedge fund, so they care about money mainly. I don't know, doing processing. And Kubernetes is a mean to an end, right? In the end of the day. So and you talked about it a bit, but I'll be happy if you can maybe deep dive a bit more on that. First of all, how much time did it took you guys, right? To do this thing, and also maybe share a bit of the challenges of how did the rest of the company, the one that were not part of the team, were they happy moving to Kubernetes, moving from Mesosphere? I'll be happy to hear a bit more about that time, because I think migration is something that almost all companies are in one or two phase of the migration. I don't know a lot of legacy 10 years old companies that are 100% on Kubernetes. And I think this switch is one of the hardest thing that for people. So yeah, if you can share a bit.
Yeah, it's a great question. So it was interesting. So this fintech, like a lot of New York finance, was hiring the highest caliber people, But it's interesting in finance is they build software different because it's usually not 24/7. They sort of know you can turn the service off at the day. So what they end up is building very bespoke solutions to particular problems that are very low risk, actually. Like, again, you don't want to be the finance company that flips the wrong feature flag and loses millions of dollars or billions of dollars. So they're very risk resistant, actually, in places, in the platform layer, in places where they've got their own innovation stack where you go. So, a lot of fintech, there's a trading team, they're in colos all over the world. They don't want to touch containers. They want to run on bare metal where they control all the cores. And they want to maybe run the CI/CD containers, but on the actual bare metal, they are very attached to pets and not cattle because they know that's the place of the money. On the other side, I think what a lot of the industry sort of sees these fintechs is the data engineers and the data scientists. And they like the idea of containers in principle. So the fintech had invested deeply in their own tool set about making data scientists really productive, but it sort of missed the Python bus. And so if you went to the data scientists and asked, what do you want? They didn't care about containers either. They said, I want to get to Python as fast as I can because all the best generation tools are in Python. And so what that looks like internally for the compute team that I ran is how do you actually find that 10% of people that actually benefit from containerization? Often they have the biggest, the most server-sized, like a lot of this wasn't server-sized, it was Apache. They're the most server-sized, and they need the most dynamic capacity. And so what we ended up doing was having to build relationship. And so it was far messier than it was like in theory. And this is like why you end up compromising your vision and a lot actually get stuff shipped. So we're going to be serverless, true serverless, and we're never going to allow an NFS attachment into a Kubernetes container. You really have to revisit those decisions because if you have no one at the company actually wanting to let you start the ball rolling in the technology, then you don't get the ball rolling at all. So we talk about it a lot in the book that like what you end up doing, like there's a product management approach to this, which is really like listen to your customers as opposed to listen to your team about technology. Because winning one internal customer and another is actually what success looks like. Managerial wise, we did like a lot more embedding of our engineers in customers' teams than I had like ever done at Amazon. So, but it was just doing the right thing. That was what got my technology adopted, and so I've started getting this balance between some legacy stuff we could get rid of, but some legacy stuff we got to carry forward into a nice new clean system and make it a bit more messy.
I think like in the end of the day, the money makers for a lot of the companies are still in the legacy system. Like I worked at eBay like 8 years ago. I don't know. And I think like the most of like the heavy lifting around eBay back then, the catalog of the items was written like 12 years ago. I don't know, something like 20. And I'm quite sure that, we were like 100-person team trying to convert part of it to the new like, microservices and so on. So, like money makers are usually legacy, like in the end of the day, like because they proven themselves and no one really like to change those things. Okay, so Two Sigma, right? Like you had a lot of fun there, real hands-on platform engineer, migration from Mesos, which is also, by the way, like quite, Mesos by itself was, like I would expect them to run on bare metal, I don't know, like machines. Like Mesos is, I think, also like a step forward. But from Two Sigma, take us to the next part of your journey.
Yeah, so I ended up wanting something where it was a bit more technology, could deliver on a faster timeline, which more or less took me back towards being in a vendor. I live in New York now, and I heard great stories about this, a company everyone now knows is Datadog. But the good reputation they had is that engineers actually really, really like this tool. And like, I was used as an engineer to hating all my tools. And I don't think it was strictly an Amazonia thing. Like, engineers in general, we're very, very critical and we rely on these tools and they tend to suck a lot of the time. So the fact that Datadog had this reputation was really appealing. And so I got to go in, got to meet the CEO. I was originally managing just their original, the metrics, the type series database. But over time, we sort of pivoted to a platform versus product type organization where at Datadog, where we invested a lot in in-house stores, that was actually the equal size with the product engineering. So by the end of it, I was managing about 700. But really, it was very, very standard sort of platform engineering stuff. We had the true infra teams. We had our in-house data platforms. We had what I these days maybe call application platform, API, and all the stuff sort of attached to API, maybe identity and stuff. So that was my organization, which I ended up managing for about 3 years. And we all through COVID, we were kept growing. Like we went from 350 engineers when I joined. The total engineering org was 1,500 when I left. So a lot of my challenges actually as a leader, a lot of my challenges were actually continuing to hire. On the technical side, though, they did this big pivot actually before I joined. They decided Kubernetes was their sort of a multi-cloud play. It was like customers want their observability tool on the same cloud provider that they're on. So we need to be a true multi-cloud company. Kubernetes is a platform that offers multi-cloud. So they actually started that journey before I got there. That journey for Datadog ended up taking 5 years. We ended up finishing it just as I was leaving in March this year.
So maybe like take us a bit into like you are joining like Datadog, which is like this is a company that really like lives and breathes like technology, right? Like that's the core, that's the value, I guess. Like that's the main thing that you did. So was there like a platform engineer when you joined the company? Like there's always the question of like a bit, right? Like autonomy, like every team can do whatever and like raises a platform. So how was that though? Was there like a centralized team that you created it? So share a bit about like the model that was when you started and maybe when you ended.
Yeah, when I joined, engineering was 350 and very, very aligned with the vertical. So at the time there, we talked about the 3 pillars. Well, that was 3 big engineering orgs. There was sort of like data science and data engineering on the side. Then there was this infrastructure org. Infrastructure at the time, this was when SRE was high. They had this term DRE. So they sort of had, so I ended up taking this org over maybe 7 months into my time there. They sort of had 3 main pillars, which was a compute team, which was all get us onto Kubernetes as fast as we can. They called a Eng tools team at the time that they kept renaming themselves. But this was developer experience or engineering efficiency. Basically, how the hell do we tool all this stuff? Because it turns out Kubernetes wasn't coming with a lot of this for free, and like everyone's Docker container journey was different, frankly. The final thing they had was this SRE DRE org, which they ran all the open source like Apache, Cassandra, Kafka. And it was also just like the unloved tool, so stuff like OS upgrades. And so it was this classic thing I think maybe the industry sort of saw, whereas SRE all the time just became the dumping ground for all sysadmin type stuff that wasn't clearly a platform yet. And so that was their org when I got there. Honestly, it didn't change too much over time, but of course we did raise the standards of what those orgs actually did.
Okay. So, walk me through, like, in Datadog, was the problem, like, you grow a lot, right? Like, it was like building a product while as a Datadog customer, like, you got more and more customers, right? And more features and more capabilities. And, like, also a couple of, like, acquisitions as well, right? Which is, like, how do I integrate something which isn't mine? So I'll be happy, you really led a big team in a like hyper growth, or at least like a very growth like phase that also had acquisitions and so on. So maybe like share with me like a 1 or 2 challenges or like success stories from that time.
Yeah, I think I'll give these guys a lot of credit because a lot of data success is based upon them. But so there's this French company called Logmatic, who was essentially the basis of Datadog's log product. And their technology is now a lot of the basis of Datadog's orbit technology. We sort of blogged publicly about their V2 system called Husky. And it really is our fundamental storage technology. Not rocket science. It's a column store on S3, what a lot of people are doing. Very, very hard to build that specialized to the use cases while we were dealing with integrating a different company's culture, essentially integrating a different company's technology. So Datadog had made, I think, a very astute decision. They're a Python shop early on. They saw Go take off. They got all on the Go train. So all the tooling was all about that. Then they did an acquisition. That was a Java shop. It was interesting. I think the CEO made the right decision. Like sometimes with smaller acquisitions, they get forced to rerun everything. I think Olivier, the CEO of Datadog, he's like, part of it was Datadog's own benefit to have a decent investment in in-house Java, because of course that made Datadog's product better in terms of helping Java engineers, like really allowed that dog moving loop. What that meant though was the infrastructure team which was very US based, very New York based, had to support now a bunch of French people who already had their own infrastructure, already had their own tooling, had a completely different tool set. how do you integrate that together? I'd say it's one of the, like, Datadog was very, very good at keeping the culture, like everyone trying to work together, which other cultures sometimes struggle with. I'd say they needed that because the integration challenges were just all over the place. Like, it was like completely different tool sets, completely different libraries. They had the W Java, actually, the data engineering, but data engineering was nothing like online services with Java. So it was more, I'd say, like, a lot of the challenges here, like a lot of the management, like you get to little things like, Datadog already had a deep investment in Kafka. This team did Kafka entirely differently. And so the two-person team who was essentially managing Kafka had this new company say, well, you need to take over our Kafka as soon as possible. And they're like, well, we're burning out doing Kafka for the rest of the org already. Why don't we take on a completely different way of Kafka? And so what we had to do there, of course, was build up our automation, build up our abstractions around Kafka. But that takes years in the end. And so what you're constantly doing is compromising, okay, how can we help you a little bit while we build the platform? I guess in a lot of ways, it just goes back to the AWS story. It's always, you have this V1 mess because that's what you get product market fit. How do you actually build that up into a platform? And it's always horse trading. Like, it's some amount of building the V2 and it's some amount of just getting the platform engineers to just go help the team who is in total pain right now supporting high growth on their product. And so that's a lot of work. My management just was a lot of, being the adult in the room who people trusted to build, to make the right compromises. And then they could work happily together. But it always was a compromise on how fast you move to the V2, how much you go about the V1.
Mm-hmm. I think like it's always the struggle when you have like V1 and V2. Like, I think like that's, like we said, like the moneymaker is usually also like the V1, like usually.
Yeah. But this is young. So you're totally right. But this is like younger ones where everyone knows it needs to be replaced. Because it's like, especially when you're growing 100% year over year, you're getting headcount in the future to a later replace it. We get most of this is like, but very early on, but it's still like, that metaphor, which is like changing a car as it goes down the road. You have that problem, but you also just have the V1. Like, the V1 is still carrying the business. And so it's a difficult challenge, but it is, I think, like, you always look at it as an idealist engineer. It's like, well, could we do better? But if you actually believe in product first growth and agile product market fit, it's just how it's going to happen. And good management is working out how to succeed and how to, when it's all said and done, you have good platforms, even if you didn't start with good platforms. So that's sort of the way I think about it.
Okay. And so, like, you finished like 4 and something years in Datadog, and now you're kind of resting. But I know that you have quite a lot of, thoughts, not necessarily on platform engineers, but even maybe like one meta level, like how do you manage platform engineers, or what do you do when the organization is really big? So I'll be happy to hear a bit, how do you see the challenges? Why is it interesting? When should I care? What should I do if I'm a big org? So go for it.
Yeah, I'll start. And sometimes I had a little bit of reputation totally for trashing Google, but it was a little bit like it came with a tremendous amount of respect for what they did, and then finding out actually from talking to people internally that sometimes what Google did internally, when it hit the outside world, sort of became this other thing that it sort of wasn't. And so I sort of saw, as an Amazonian, which was sort of this culture of you build it, you own it, you run it. I saw this thing called SRE come. And it was sort of like, no, you need to split your org and you need to use error budgets. And to me, it was totally antithetical to building good platforms, building good engineering teams. Like, it seemed to like put this big dividing line. But like, you can sort of do this dichotomy. Like, I talk in modern writing sometimes about the old dichotomy of system administrators and software engineers. And, it's not a dichotomy. Like, but it is clear there are two types of people. There are people who see infra problems and love to know down on them. Then there's some type of software engineer who sees infra problems and go, well, this is a shitty system. Like, these leaky abstractions should, I think, like, it's clear that in our industry, we see these types of two people, and success is having them work happily together, and failure is having them revert too much inside their own silos and say, well, you get the ops team pointing at each other, the old thing. And so, as I thought about Datadog, and I did think Datadog, like, the whole idea of a product was bringing dev and ops together. Like, I think Datadog's culture was trying to do it, but it was a continual challenge to sort of make that happen. And I thought SRE, honestly, made things worse. Like, I think everyone we sort of hired is like, oh, the SRE book says we all need SLOs and error. But the real world didn't work like that. The real world is engineers sitting side by side working together to solve problems. It's not these abstractions. The abstractions is sometimes keeping leadership teams accountable for what they say. But you have to be very selective because you don't want leadership teams to sign up for 50 SLOs because they want to be accountable. So sort of coming out of Datadog, this has been a passion. It's been a passion at the Two Sigma and at Datadog. And so there's a woman, her name's Camille Fortier. She has a book called The Manager's Part, and she was with me. She was my manager actually at Two Sigma. And so when I left Datadog, she's like, we have to write this book on platform engineering now because we have to say it's about working together with a product mindset on how you build platforms. And so that's sort of what I've been doing the last 6 months. It does make you you sort of revisit why are we here? Why are we talking about platforms? And what you get is between Kubernetes and the public cloud, the actual surface area of infrastructure has maybe become more complex. Terraform is this excellent metaphor because we all hate Terraform. We all hate all the complexity in Terraform. But Terraform just represents the complexity of the cloud underneath. It's just this a lot of APIs. So you sort of get that aspect. Then you get this aspect that we sort of talked about, that the V1s usually are platforms. And you sort of have to work out how to retrofit platforms into what was V1. And so those are the ideas that we're thinking about as we write the book. It turns out though a lot of it is just balance management. How do you balance the different personality types? How do you balance V1 versus V2? How do you balance product mindset versus operational mindset? It's not actually, we don't feel like we're writing anything groundbreaking, but we do feel like, especially versus other movements, we do feel like something saying, hey, you have to balance these things is something that maybe needs to be said. So that's what we're doing. We're about 90% of the way into first draft. So it's painful like every book, but we'll get there.
Well, I think a lot of people are trying to figure out exactly that, and there's the question of the abstraction, and there is the fact that in most product there is a complexity. It's not a question of Terraform, it's not even a question of the cloud. There's something complex that is the IP of the company that is in its heart, and trying to abstract all of it is usually for a real company, right? Not a small startup. Something will break, and the question is what, and once it breaks, what do I do? So I think those points are spot on. I wonder since leaving Datadog, I know that you are talking with quite a lot of companies, right? Wonder if you're seeing anything interesting. Let's talk a bit about the trends that you're seeing in companies or anything interesting in the industry.
It's interesting. I sort of have this triad line, which I know is sort of against Kodo's mission, but it's I often talk to VCs. I talk to so it's I love to kill Kubernetes, and it's interesting that lots of people are struggling with the complexity of Kubernetes, and it's just if you talk to people who want to be vendors, a lot of what they're trying to do is okay, how do I build observability in this space? If you talk to customers, of course, it's how do I actually just succeed in this space? The challenge that I find with observability first approaches is most engineers are not going to be able to understand the depth of complexity there. And so I think the challenge for the observability companies is it's not enough to present observability. It's how do you simplify that for most users? And I guess you see runbooks as a good solution. I get excited about the networking layer. Can you actually simplify the networking layer? But just especially as it ties to auto scaling, I find that's pretty complex. I think everyone's sort of just dealing with the this is not, as an abstraction layer that tries to map to their business problems in the past. It's still definitely not there. It's just all the usual stuff. It's stateful workloads. It's should you actually be running? I saw something on how can you should you actually be running Postgres on how can you use, and Datadog was actually investing heavily in it. But there's lots of questions as we did it.
What answer, Ian? Should you run Postgres? I think the answer is yes or no.
I think the answer is today Kubernetes has got to the point where it is actually fairly safe to be able to reason about the properties of the faults of the underlying technology in terms of how it would impact Postgres. But the historical fear was right. Okay, well, something's going to come along. And I was at Datadog when their outage happened. You can read sort of how Kubernetes made that worse. And the worry is, right, you have something at the infrastructure layer, the Kubernetes layer, goes and shoots a bunch of VMs that don't need to be shot, and you lose a bunch of state that you really didn't need to lose. And that was always the question, I think, with like the old school DBAs who had their pets, and like they could reason about their replica, oh, this has got a replica. Is when did the abstractions just allow them to have a lot of confidence that they weren't going to lose state, it didn't need to be lost? It's one thing to say stateless. It's another thing to shoot a VM with a bunch of state that doesn't need to be shot. It's another thing to shoot 100 VMs that don't need to be shot and worried about auto-scaling to bring it back up. So I do think the answer is finally today that you can. But I think for a long time, Kubernetes was sort of in denial that it wasn't quite ready for those types of workloads.
No, I agree. I think, I think like state in Kubernetes, once it will stabilize, which I think is like 3 more years or something like that, it's going to be like a really like a revolution. Once, you can't be RDS, right? Or like SKS. I don't believe you can build it in a house, right? Like so many different reasons. But I think even if it would be much, much more easier to run and stable, I think today what most cloud providers have is their the S3 and like the RDS and the SQS. And if some of it can really migrate to Kubernetes, I think it is going to be like a game changer in how people perceive Kubernetes. But Ian, like what's your, usually like I ask the interviewee, like what's your prediction? Like where are we going as an industry? Feel free to talk about it from a cultural, from a tech, from a Kubernetes. Choose your, but where are we like in 5 years? We're going to check it. Yeah.
It's partly, the author of the book of platform engineering, partly as I've read about platform engineering and sort of this idea that you actually have to do software development on a house platform. I had to keep asking myself why. Why does it make sense that this doesn't get commoditized? And what you get is that each company's growth in terms of both the products that it builds, in terms of technologies that it uses, it's fairly separate actually. Like everyone starts off, like everyone was doing Ruby on Rails 10 years ago, or maybe 15 years ago now. They started off the same, but then they made choices. Like Twitter looks probably very, very different to, I don't know, it was Heroku or Rails? I can't remember, but they end up looking very, very different. And so what I do think, to me, sanity, what I worry about with this industry is the government. You see this a little bit on the security side, but especially on the reliability side, is that we've been in this move fast, break things mode as an industry for about 20 years. And people just aren't going to tolerate it in a certain way. People aren't going to tolerate these, ransomware after ransomware attacks. And if we don't get our shit in order, we're going to hear it from government, like with shitty regulation that makes us put it in the system. So what makes me believe sort of in platform engineering as an approach is it's the idea that there is this path-dependent thing within any company. And there's these people who care more about infrastructure. And if you can actually get them, rather than building this lowest common denominator, we're just going to support open source and vendors in all the different dimensions they can be used. But actually building in-house abstractions that to somewhat Pareto-ize the space, right? Like they definitely can't do 100%. But if they can support 80% of the in-house users at the company, then suddenly you get much better technology that actually can, it doesn't just, like we all hate the term tech debt, right? But because it's like tech debt was a system someone else built. But we all know that tech debt is a very real thing. You just end up with these systems that you can't iterate on anymore. So my hope is that as a movement, that sort of these platform teams get a little bit more power to move up the stack, and that this actually is a good movement, that it isn't just like writing software for the sake of writing software. It's actually software that has leverage to the business. And that really our infrastructure, like it isn't like the old, I have a guy who loves small talk, loves talking about small talk. This small talk dream where most application developers do not actually have to care about infrastructure. It'd be great if we can get there. And I do think, I think we're proceeding in that direction. So that's my prediction, but it is a somewhat biased prediction of someone who spent like 6 months thinking about maybe this is the thing that finally gets us there.
Okay, Ian. Any last notes, like your book, your life, like anything else?
No, I mean, my book is in progress. It should come out early next year. We'll have a title somewhat around the name Platform Engineering, but we haven't quite worked out the title yet. It's really aimed at people who are managing platform engineering teams and just dealing, I think, with the challenges that we all know are sort of inheriting this space. So, yeah, it'll be early next year.
Okay. Ian, it's been a pleasure. and enjoy life.
Thank you.
Kubernetes for humans.